So this talk, we've been traveling for about 2 months doing a seminar on high-level synthesis and its application to machine learning, which has been a pretty deep technical dive because we've been mostly talking to hardware designers. So this is kind of removing a lot of the low-level technical details and just talking about kind of the key technology and what high-level synthesis brings to the table for doing custom designs for machine learning algorithms that you want to build into hardware. So talking about high-level synthesis and machine learning, I'm going to keep it very high level. So the whole driving reason for why people are adopting HLS and really why everyone here is talking about all these different things that are happening now in computer vision is that machine learning requires massive compute complexity. And so you've probably seen a lot of talks and people on the floor where people are building these high-performance processors that deal with these very complicated algorithms. They're extremely mathematical. They're compute intensive. And so with high-level synthesis, and we'll dig a little bit into this, our customers are basically building hardware to solve these kinds of problems. So they're custom tailoring hardware solutions to implement specific neural network algorithms, classic machine vision, and even just communications signal processing. And we'll get into why are they doing that? What are the benefits of HLS? And so we'll talk about that, and then we'll also look at kind of how do you verify what this tool is creating, because we're going to see it's kind of automating some of the classic things that hardware designers do. And so being able to understand how to verify it is really important. And then also, when you build hardware, you're doing quantization of that original floating point algorithm, and how do you verify it against your machine learning framework? And then we'll finish up with looking at some real customer success stories. What are people actually doing? Why have they been successful? And then talk about where we're going to go from here.